IKIM FM, inspirasi utama anda.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. Salam sejahtera and a very warm welcome to all our listeners of IKIM FM. You are with us once again in Man and Nature every Sunday, where we reflect on the relationship between humanity, the environment and the future that we are shaping together. This program is produced by Batrisha Afrina. I am Dr. Zul Ilham Lubes, and it is a pleasure to be with you today. Dear listeners, in today's world, energy is no longer merely a question of supply and demand. It is also deeply connected to sustainability, ethics, resilience, and human well-being. The current tension happening in the Gulf region affecting important maritime routes and global energy flows, reminding us how vulnerable conventional energy system can be. In such a moment, it becomes even more important to explore cleaner, secure and future-ready alternative energy. This is very much in line with our broader theme, navigating future challenges in knowledge, ethics and human well-being. The future of energy is not only about technological innovation, but also about making wise and responsible choices for the society, the environment and generations to come. To help us to reflect on this important subject, we are honoured to welcome Associate Professor Dr. Firdaus Muhammad Sukki from the School of Computing, Engineering and Built Environment, all the way from Edinburgh Napier University, United Kingdom, who will be speaking on the future of solar energy, trends, technology and opportunities. Dr. Firdaus, welcome to Man and Nature on IKIM FM. How are you today, Dr. Firdaus?
Alhamdulillah, I'm good. Thank you so much, Dr. Zul, for inviting me.
How about the weather in Edinburgh? Is it like sunny or cloudy today or raining?
This week we are blessed with the sun actually after months and
Alhamdulillah.
months of clouds. Today, I think for the past 2 days we get quite a bit of sunshine. Temperature wise around 18-20 degree, but yeah, it's very good.
Pleasant temperature and nice bright day. Okay, Dr. Firdaus, to begin our discussion, perhaps you could briefly introduce to our listeners on IKIM FM the focus of your research that you are currently doing in Edinburgh Napier University with regards to solar energy and what areas you have been most involved in over the years.
Okay, my research focuses on making solar energy more efficient, affordable and sustainable. And big chunk of the technology actually revolves around the development of solar concentrator system. So at a high level, I am interested in how we can get more energy output while using cheaper, less expensive material. So as you know, the traditional solar panels rely heavily on the semiconductor material like silicon. And this material is actually very, very expensive if you compare with other technology, especially when you try to scale up. So instead of spreading the sunlight evenly across a solar panel, I developed a system that will be able to concentrate the sunlight into a much smaller area where a solar cell is attached. So the idea is if we can use a smaller amount of expensive material, so this will basically cut the cost down, but at the same time trying to keep the system maintain the same electrical output compared to the traditional design. So it's more about trying to balance the efficiency and costs, and hopefully by doing so we'll be able to create a cheaper product, cheaper type of solar panel for the consumer. In addition to that, I also explore alternative material for solar technologies. So this is a research area that I developed together with a collaboration of universities in Malaysia. So one area I've been looking on is through the use of natural dye. For example, the pigment extracted from mushroom. So we create a solar cell we create a mushroom-based solar cell, and this work together with the solar concentrator technology. So the motivation for this is to move away towards a more sustainable, non-toxic material, and also trying to reduce the reliance on synthetic chemical. More broadly, my research is not just about improving the individual solar cell, but thinking about at the same system level, how these technologies can be integrated into buildings, urban environment, and hopefully everyday infrastructure. Okay, so overall, I would say the work that I am currently working on is a combination, intersection of optical design, material innovation, and sustainable energy system, with the goal of making solar more practical and accessible for larger scale, and hopefully further driving the cost of the solar system, either in the UK or even in Malaysia.
Thank you, Dr. Firdaus. That could give our listeners a very helpful starting point, and shows that solar energy research is a broad and dynamic field, involving not only theory but also practical solutions that hopefully can benefit society in meaningful ways. Solar energy, Dr. Firdaus, of course, is not something entirely new, right? So it has been discussed for many years. So from your perspective, what makes your work, I think, is related to the solar concentrator and the alternative material, which make it different from all the research that have been done earlier. And in your view, what should Malaysia focus on, mostly in developing its solar energy sector to be effective?
Okay, thank you, Dr. Zul. I agree with the point. That is a very fair point, I would say. Solar technology has been around for many years, for decades already. Even back in, I think, early 90s, when the first solar cell was discovered, the efficiency was very, very low at that time. I think close to 1% efficiency. That was the first efficiency of solar cell. And it has evolved for the past decades to become quite mature, and I think being installed in many parts of the world. But I think what important is that even though the technology already exists, and some would say they are mature, there are still several challenges that we can address to keep improving the technology for the future of mankind. For example, I know we believe that solar is the one of the alternative to the fossil fuels, but the main issue is still cost. Cost is still the major barrier, especially in developing countries. So even if you want to have a large-scale deployment, installation, if you look at the situation in other countries, developing countries, for example, Nigeria, Malaysia, they still perceive solar is expensive, especially at the starting point. If you want to install the solar panel, in those countries, in Malaysia, I believe you can have, I think, around 3,000 to 5,000 per kilowatt. Okay, those are some of indicators depending on the installation site, depending on the complexity and so on. So there are still issues of efficiency, particularly in the real world condition, which are often different from what we achieve in the control lab environment. And then there's the issue of integration. How can we actually integrate solar technology into buildings and cities in ways that we want to see that looks aesthetically pleasing. Okay, so what makes my work a bit different is, first, I try to address the issue on the cost, and after that, there are also several challenges rather than not focusing on that particular one issue. So I look at the cost. Okay, for instance, solar concentrator instead of using expensive PV material. Okay, according to IEA, International Energy Agency, uh, 35 to 50% of the cost is coming from the semiconductor material itself. So if we can use only a fraction of this expensive semiconductor material while maintaining the same electrical output, so it will translate to a cheaper cost. Many more people will be able to utilize this technology. So how can we use this? How can you use only a fraction of this expensive material? We introduce the technology, solar concentrator. From the name, it concentrates the sunlight into a smaller area. So in theory, it should generate the same electrical output. So this will immediately reduce the use of expensive PV material and potentially lower the cost, while at the same time, we maintain the same high performance. At the same time, beside the cost, we are looking at sustainability from material perspective. Okay, so if we can create a cheap solar concentrator through reducing the use of expensive PV material, that is one way of reducing the cost. Another way, why don't we create a much cheaper solar panel itself, which I hope you may be heard to the terms of dye-sensitized solar cell. This is another third generation solar cell, which is cheaper, and we try to use a non-toxic alternative, which is like the use of natural dye from mushroom. So this way, we are looking at the broader idea around the circular economy. We try to reduce the environmental impact over the full life cycle of the technology. So from mushroom, it can be for the food, and it also can help in terms of the energy generation. So this is another angle that we look at. Create a totally different type of solar cell, and it is a cheaper version. Okay, so first using the concentrator, the second one use a different type of solar cell. So another aspect that I also take more of a system level approach. So we look at not only addressing the efficiency, but also how we can we look at how the entire system perform, how it is deployed, how it is integrated into the building, how it can contribute to overall energy ecosystem. So I would say the novelty in my works come from combining all these technology that we need, the optical engineering, material, and sustainability, and try to basically integrate this complex element together into practical real world solution. So what is it? How can this technology benefit Malaysia? From a research perspective, even from the location wise, I think Malaysia is blessed with sun compared to the UK, and there are huge prospects to bring this technology in Malaysia. Okay.
Thank you, Dr. Firdaus. Those are very important points to know that although solar energy is have been here with us for many years, but still cost is still the barrier, and it could still be expensive in many parts of the world. And you are also looking into finding or resourcing sustainable materials and improving the system. So, Dr. Firdaus, one term that may be unfamiliar to some of our listeners is the solar concentrator that you mentioned just now. So, could you explain in simple terms what is a solar concentrator and how it works and why it matters in the wider conversation of solar technology?
Okay, thank you so much. Yes, I think it is important to understand what is a solar concentrator. So just from the term concentrator, the idea is we want to concentrate or focus the sunlight into a specific small area. So think about it in this way. I think a lot of us already know about magnifying glass. Okay, so when you hold on to magnifying glass, You can actually concentrate the sunlight onto a spot on the paper and you can burn the paper. I think this is a classical example of a solar concentrator. So that magnifying glass is actually one classical example of solar concentrator that has been used in many parts of the world, and I think we have used it for our primary school science experiment. So if you've ever used this magnifying glass, you notice that it can focus the light into a very small area. The spot will be brighter, it will be intense sunlight, and you can burn a paper, burn leaf, for example. Okay, so a solar concentrator basically works on a very similar principle, but in a much more controlled and engineered way. Until now, there are already many variations of solar concentrator design. Okay, so instead of just randomly focusing the light, what I do is I design an optical design or the optical concentrator using a lens or mirror, which will be able to collect the sunlight from a large area, and then we will direct the sunlight into a smaller area, and at that particular small area, that is where the solar cell is attached. Okay, so the key idea is that the high efficient solar cell, which we know is very expensive, so instead of having a big panel of that expensive material, we put only maybe around a tenth of the size, 1/10 of the size, and we concentrate the sunlight into that small tenth area. So we feed this sunlight concentrate into the area where we put the solar cell. So this means you can generate the similar amount of electricity while using only a fraction of the solar cell, and this translates into a reduction in the cost. Okay, so depending on the design, the system, the solar concentrator can be created to track the movement of the sun, to maintain its optical performance. So they are designed, the lens itself can be fabricated, can be created using different type of material, can be from mirror, it can be from plastic type material. Some classify the concentrator according to the design. They say there's the 2D design, there's the 3D design, and so on. There are a variety of it. So overall, this concentrator, depending on the design, is actually a way to make the solar system more efficient and cost effective by using this smart optical lens optical design. Okay.
Thank you, Dr. Firdaus, for explaining so clearly. It is always valuable when complex engineering ideas and terms can be translated into language that the listeners can understand, because this is how knowledge become more meaningful and more accessible. We'll discuss more after a short break. Stay tuned with us. IKIMfm, thank you.
Focus on the positives. Have positive energy. Everything happens to you by the will of Allah. Our beloved Prophet ﷺ said, how wonderful is the affair of the believer that everything that happens to him is good. If something good happens, he praises Allah and says Alhamdulillah, and that is good for him. This does not apply to anyone except for the believer. If something bad happens, he is tested with patience. So good is good, but bad is good also. This is the fate of Allah. You have to face challenges to the best of your ability, but always be positive. Focus on the positive. Always keep smiling. Spread salam and spread smile. This is what the Prophet ﷺ said. He said, do not belittle any good deed. Even meeting your brother with a cheerful face is considered to be charity. And this is recorded in Muslim. The next one is give charity. Even if you get a small amount of money from your parents as pocket money, even a small amount, a few ringgits to the masjid or to somebody who is poverty stricken, give it to them without telling anybody. Do it for Allah's sake only. You will increase your provision that way.
Hiburan mendidik jiwa.
Sebelum tiba indah, sedih sebelum gembira.
Hanya yang terbaik di IKIM FM. Inspirasi utama anda.
Looking at countries like Malaysia, Dr. Firdaus, with abundant sunlight throughout the year, how could your research and innovation in solar energy bring practical benefit to a country like ours, tropical country where we have almost 365 days of sunlight, whether in terms of sustainability, affordability, energy security, or even rural development? If you can explain a little bit for us.
I think Malaysia is actually in a very strong position when it comes to solar energy. So first of all, as you mentioned, Dr. Zul, Malaysia, it has a high solar irradiance, solar energy, and fairly consistent sunlight throughout the year. So this is naturally suitable for solar generation. Unlike in Scotland, for example, here we only have the sun for or during springtime or summertime. It's a very short period, 2 or 3 months, and then after that it's gloomy, cloudy, rainy areas. But in Malaysia, that is already a extremely good advantage in terms of the amount of solar energy received. Okay. Next, the real opportunity here is actually to expand solar in a way that is both economically and environmentally beneficial. So as mentioned, the cost is one of the key area which we try to achieve. But looking at the manufacturing point of view, Malaysia is also one of the good country. We have a lot of manufacturing capabilities, and in terms of the labor cost, Malaysia is also in a much better position compared to the Europe. Okay, so that will be able to allow this technology to be mass produced at much cheaper cost if you want to develop it in Malaysia. And next, also we look at in terms of the urban setting. We know Malaysia in a dense urban environment, like in Kuala Lumpur, for example, in many parts of the in Malaysia, many cities in Malaysia, we have limited space. We don't have large rooftop areas. So what is unique about this technology? It can be utilized, it can be installed in this smaller area, and we don't only necessarily look at the rooftop installation. We are aiming to integrate this technology in many section of the building. It can be on the building facade, it can be on the window, it can be on the roof. So they are already, in terms of the area, there are already a lot of opportunity to be installed in the modern environment setting. Okay, there are that would be added advantage in Malaysia. Especially Malaysia, we have a lot of tall buildings, high rise, which I think has the potential. So a lot of these glass facade can be utilized to be installed with this technology, the concentrating PV technology. So so we have look at the manufacturing, we have look at the urban setting and by the location, and from the sustainability angle, the use of natural and bio-based material could also align with the environmental goal, and we can even leverage on the local natural resources. We know from the mushroom-based solar cell, Malaysia is one of the good producer of mushroom, so we can leverage on this to develop the mushroom-based solar cell together with the use of solar concentrated technology. So overall, I think the impact can be across not only the cost aspect, we look at the efficiency, urban integration, and also the economic development.
That is very encouraging to hear, Dr. Firdaus. It shows that research is not something distant from our everyday life. Perhaps we can utilize mushroom and also eat waste and perhaps other agricultural residues too. Hopefully this could contribute to further to national development, environmental care and the well-being of our community. Dr. Firdaus, you are currently based in Scotland, United Kingdom, where research ecosystem might be different from Malaysia. So from your experience, how would you compare solar energy research and development in the UK with what we are seeing now in Malaysia, and what lessons or perhaps something that you have observed and could be considered by both sides?
Okay, yeah, I would say the UK and Malaysia have quite different strength, but they are actually very complementary. So, for example, in the UK, there is a strong focus on advanced research, particularly in areas like material science, system design, and maybe theoretical modeling. There's also a well-developed policy environment around renewable energy, which helps guide innovation and deployment. And at the same time, the UK benefits from strong research infrastructure and international collaboration network, which allows for cutting-edge development. So I remember when I started my research in solar energy back in 2008-2009 period, when I first got this offer to conduct the research in solar concentrator, I approached a few agencies in Malaysia, but because at that time the awareness was quite low, there is no emphasis on solar energy research, I was unable to secure funding, and I was at that time lucky, Alhamdulillah. I managed to secure the funding from the UK government, so to conduct this research. So after a few years, then only Malaysia started to get into this research. So they are still, I would say, progress be made in terms of the research development in Malaysia, but we are slowly closing up this gap. So Malaysia, I think, is in a way trying to also make a better research through the use of policy, through the government support and so on. But we are slowly getting there. Okay, so Malaysia, although research may be slightly behind from the UK, but we are catching up in terms of the development. I have seen a number of universities in Malaysia that already have quite a good lab, already have a quite research output generated from solar energy areas. I know, for example, Universiti Malaya is one of the strong contender in the solar energy research. Universiti Kebangsaan Malaysia, IKIM, they have the Seri Research Centre that focus on the solar technology. UITM, also another good university that have strong presence in terms of solar energy research development. So I would say Malaysia is slowly catching up, and I'm not surprised if Malaysia will stand together on same level with many universities in the UK. However, for now, we can also look at other strengths in Malaysia. So we have the strength in terms of the solar resource availability, manufacturing capability, and scalability. So the condition for deploying solar technology are much more favorable in Malaysia. So if you can see now, there are already a lot of solar PV installation in Malaysia, and compared to the UK, because here in the UK, even in Scotland, there are less installation of solar PV technology. So in the practical example, Malaysia has a much more favorable condition for the installation. Okay, so UK might have a strong in developing new ideas and technology, but Malaysia is well positioned to implement and scale this technology. So that is why I think collaboration between Malaysia and the UK would be, very, very powerful in the future. You can combine research depth with real world application, which will help to accelerate the transition from lab into the market. So from a personal perspective, being based in the UK might give me access to advanced research, but I am actually very interested in how this research can be applied in regions in our home country, Malaysia, where the real impact can be seen at a much larger scale.
Thank you, Dr. Firdaus, for a comparison that is very insightful. It reminds all of us that international experience can be very valuable and important, but at the same time, local strength, resources and realities must always be part of the conversation if you want lasting and meaningful progress. So before we talk about the future of solar energy, we are going for a short break. So please stay tuned with us, IKIM FM.
According to WHO, nearly 1.3 million people die in road crashes each year. On average, 3,287 deaths a day. Drivers who are texting can be 23 times more likely to crash than non-distracted drivers. Posting to social media, checking email, programming a navigation system, or watching a video are among the many excuses people tend to give when they are asked why they text while driving. Please be aware of the dangers and keep your attention on the road, not on your mobile phones or other mobile devices. Texting and driving is dangerous. Road traffic crashes are predictable, can be prevented. Help saves lives. Don't text and drive.
Kuching 93.7.
Welcome back to Man and Nature. We are still with our guest today, Associate Professor Dr. Firdaus Muhammad Sukki from Edinburgh Napier University, all the way from Scotland, UK. So, Dr. Firdaus, when we speak about the future of solar energy, we often hear a great deal of optimism. But every technology also comes with challenges, barriers. So in your view, what are some of the biggest challenges facing solar energy today? Whether it could be whether technical, economic, policy related, or even social. Can you explain a bit to us?
Okay, thank you, Dr. Zul. In terms of the challenges in solar energy today, I would say there are three main challenges that I see this technology, this industry is trying to address. The first is the trade-off between cost and efficiency. So the most efficient solar technology, very good. However, it still tends to be more expensive. While the cheaper option may not it's good for us to adopt the cheaper option, but it might not perform as well compared to the previous one. So the challenge is to find ways to achieve both high efficiency and affordability at the same time. So this is the first challenge. The second one, I would say, is the energy storage issue. Okay, solar energy is intermittent depending on the sunlight, and during nighttime we don't get any power during nighttime. So there's no sun, so you won't be able to generate any electricity during nighttime. So it can vary also with weather condition, especially in many parts of the world. In a four-season country like the UK, we have less sunlight. So intermittency is a problem. So to make this solar a more reliable energy source, primary energy source, we need to have effectively a very good storage solution like a battery, which add additional cost and complexity. So that is the next challenge, the energy storage. And the third challenge is trying to integrate this technology into existing infrastructure. So most buildings were not originally designed with solar in mind. So to retrofit, to integrate this technology into that building can be difficult. There are considerations around the aesthetic, the structural design, and also the cost itself, so added cost to the development. So I would say this, in my work, I want to address these challenges. How can we create a solar concentrator to improve the cost efficiency balance and explore ways to better integrate this technology into the building? Okay, there are also some emerging challenges, I would say, that we just discovered this. For example, recycling of solar panel, the end of life, and also to make sure sustainable supply chain, which are becoming increasingly important as this industry grow. So overall, the challenges now is not just making solar work, but making it scalable, reliable, and we try to integrate this into our daily lives.
Oh, despite of the challenges that you have mentioned, for example, you mentioned trade-off between cost and efficiency, energy storage, including batteries in order to overcome intermittency. and then the integration of solar system into existing system, right? Retrofitting could be costly too. And another new challenges when we already have a lot of solar panels, then we have to deal with end of life of the solar panels, right? Recycling of it. So those are new challenges. So I'm sure there are also many exciting developments ahead. From your perspective as a researcher, what excites you most about the future of solar energy, and what possibilities do you think we should be paying attention to in the years ahead, in the near future?
I think what really excites me is the shift in how we think about solar energy. Okay, traditionally we think of solar as just a panel on the rooftop or a large solar farm, but as we move towards the future, the perspective started to change. This is where we think the new perspective is how solar is embedded into the environment around us. For example, solar technologies not only can be integrated into building facade, windows, and even in the design element. So there are many areas in the building that we can actually integrate the solar technology. So this opens up a lot of possibilities, not just technically, but also architecturally and culturally. Okay, we have the rise of electric vehicle, for example, in Malaysia. So how can we address this? Solar is also another solution. We can create solar charging station, solar car park. So this also create a new environment to support infrastructure, not just the building, but also other infrastructure. For example, the closest one is the electric vehicle requirement, the charging station for electric vehicle. Another exciting area that I also see is now combining solar with digital technologies like the AI and smart grid. So this will allow for much more intelligent energy system, where the generation, the storage, and the consumption can be optimized in real time. I think we have a strong push towards AI in many sectors, and this is also another area that we are trying to tap into. And I have two PhD students who are currently working on this AI-related technology to improve the development of solar technology in the future. There's also a strong push towards sustainability, not just in terms of clean energy, but in the material use. Moving forward, what are other materials that can be used to develop the solar technology? So that is also another interesting area that I want to see in the future. So I think the future, if solar is not just about efficiency, it is also redefining how energy is generated and used in our everyday environment. So solar definitely has the potential to become the primary energy source rather than an alternative. And how we progress, how we transition to this future is what I think is more exciting to see in the future.
Oh, that is truly inspiring and good to hear, Dr. Firdaus. As Khalifah to this world, of course, we will have to ensure that the amanah, the world that has been entrusted to us, can be taken care in a very good manner, and hopefully by utilizing solar energy and doing more research in solar energy, let us hope that the future of energy can be cleaner, smarter, and also just, meaning it could be affordable and available to all, provided that we continue investing in knowledge, innovation, and responsible research. So finally, to share with our listeners today, Dr. Firdaus, to many young Malaysians who may be listening today, especially students who are interested, it could be anybody who are interested in science, engineering, and sustainability, because now is the age of lifelong learning. We are not only, it's not limited only to young generation, right? So it's lifelong learning. So those who are interested in science, engineering, and sustainability, what advice would you give to those interested who hope to contribute in the field of renewable energy, particularly solar energy in the future?
Okay, thank you, Dr. Zul. I would start by saying that renewable energy is actually a much broader field than many people initially think. Okay, a lot of people associated or thinks solar energy from the engineering lens, engineering perspective, but in reality, it's actually highly multidisciplinary area. Okay, we not only need people from engineering, but there are also other sides that require attention. We need people from the data science, we need the policy, we need the economics and businesses. So for example, the data science, these data scientists will play a role in energy forecasting and optimization. We need people, the policymakers, because these policymakers will shape the regulation and incentive that will definitely drive the adoption of solar technology. Another piece of advice would be to focus on real world impact. It is great to do research. We learn about the technology, we create the prototype, but the most valuable work is the kind that actually get implemented and make a difference. If you can bring this technology into the industry scale, implement in the actual setting, that is the one we are trying to achieve. A real world impact. Okay, so I would encourage students to look for opportunities to gain practical experience. It can be internship, it can be small projects, even collaboration with industry. So it's also important to stay adaptable. Okay, it's in a changing world because this field is evolving very quickly. So new technologies, new role, new challenges are constantly emerging. So you need to be able to adapt to these changes. And finally, I think it is important to have both global and local perspective. You need to learn from what is happening globally and think about how those ideas can be applied to local challenges in Malaysia. So there are huge opportunities right now in renewable energy for the young minds, and it's a field where you can really contribute to shaping the future, not just of the technology, but as a society as a whole.
Thank you, Dr. Firdaus. That is a very meaningful message in order to encourage everybody to work on towards giving real world impact. The future of renewable energy will depend not only on technology, not only by the engineers, but also on the passion, values and commitment of people from other disciplines such as data science that you have mentioned, policy, businesses, and those who will carry this work forward. So, Associate Professor Dr. Firdaus Muhammad Sukki, thank you very much today for joining us on Man and Nature and for sharing your valuable insights all the way from Scotland, UK, for this timely topic in this energy crisis. So our discussion today has shown us that the future of solar energy is not only about scientific and technological advancements, but also about how knowledge must be guided by responsible research and concern for human well-being. To all our valued listeners, thank you for being with us throughout today's program. We hope this discussion has offered useful insight and meaningful reflection on how renewable energy, particularly solar energy today, could help us and help us to be more sustainable and closely connected towards facing the challenges of the future. Please continue to join us in Man and Nature every Sunday, only on IKIMfm for more thoughtful discussion under this year's theme, Navigating Future Challenges in Knowledge, Ethics and Human Well-Being. Until we meet again, Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Waalaikumsalam.